Hello dear children, this is a ninth lecture on kinematics. Of course, it is going to be very small. Children, it's a very short. Okay, so in a previous class, we discussed about motion under the gravity. There we had three cases, where first case what? Body is thrown downward direction, top to bottom, but that to downward direction. The second case is ground to ground, like with this we are throwing and the body comes back in this path. And third case is height to ground, means we are standing on a tower or a building, we throw ball vertically upward direction, so it will go to a certain height, again it comes back to the ground. So these are the three cases which we discussed. So out of the three children, so look at the second case where the what we can say, a body or a ball, something, it is at the ground, is thrown vertically upward direction, again it is a coming back. This is a case we can call it as a ground to ground. But we discussed when air resistance is neglected. Children, once air resistance is neglected, so we could derive some parameters there. So the maximum height reached is equal to u square by 2g, and time of flight is equal to 2u by g, and the time of ascent is equal to u by g, and time of descent is equal to u by g. So if you can notice here, this is what we got. Time of ascent is equal to the time of descent. But this is possible only when air resistance is neglected. When air resistance is neglected, then only time of ascent is equal to time of descent. Then in exam they might ask a question, if air resistance is considered, can these two equal? Obviously no. Then which one is more? Either time of ascent is more or time of descent is more. So that is what actually today we are going to have a discussion. Children, only thing is that previously we did not consider air resistance, but today's class we are going to consider air resistance, and let us check which one is more, whether time of ascent is more or time of descent is more. So look at here children. So this is a case of the what we can say ground to ground only. Now this is a first situation where body is thrown vertically upward direction. This second situation, after reaching maximum height, it comes back. That we all know very well, right? Okay. Children, here air resistance is nothing but what actually? Friction. Air friction. Air resistance is nothing but air friction. Children, friction always opposes the motion. Which means what here? The direction of friction is always opposite to the direction of motion. Means what? If a body is going vertical upward direction, friction acts downward direction. If a ball is coming downward direction, the friction acts vertical upward direction. This is a very important point to be noted. So frictional force always in the opposite direction of the motion. Okay, fine children. Now here body is going vertical upwards, let us say that. Okay, so let us take at any instant, let us take here is a ball or a body, anything. So it's going vertical upward direction. Okay, so its force, gravitational force, see, first of all, previously when air resistance is neglected children, here we have only one force which is acting on the body, that is gravitational force. But now as we are considering the air friction, there are two forces acting. So let us see the direction in which they are acting. So on this here, mg, weight is acting vertically downward direction, and as the body is moving vertically upward direction children, yes, air friction also, let us say Fr, air friction also acting vertically downward direction only. Children, in a time of ascent, u by g, actually it's a u by g is what here? Acceleration, net acceleration. But here why we have taken only one g here? Because only one force acting. So there is no point in discussing about the net acceleration. Only one acceleration, that too produced by the gravitational force. But here there are two forces acting. So obviously there will be some net acceleration that we need to calculate. So if you want to calculate the net acceleration, what we must know? According to Newton's second law of motion, we must know the net force. Why children? Because we know that here acceleration is equal to F net by mass. So this is how actually we can calculate the net acceleration. Here both forces are acting vertical downward direction. So I can say here net force is equal to mg plus Fr by m. Okay, this also can be written as A is equal to G plus F net, sorry, frictional force by m. So this is what actually net acceleration acting on a body which is going vertical upward direction when air resistance is neglected. Now in this case, the time of ascent is going to be u by net acceleration is how much? G plus it is Fr by m. So this is how actually we can calculate the time of ascent when air resistance is considered. In the second case now, here the body is coming downward direction. Okay, the body is coming downward direction. So on this, gravitational force will be acting vertically downward direction mg. In this case, can you see that the air friction is acting downward direction? No. Why? Because air friction always opposes the motion, right? As the body is coming downward direction, yes. So here air friction acts vertically upward direction, that is air friction. Now here what will be the net force here? So if you want a net acceleration, we need net force, right? So A is equal to net force. See, you tell me mg is more or F. See, always according to the Newton's second law of motion, higher force minus lower force, right? So here, see, the net force will be downward direction because the body is moving downward direction, right? Obviously the net force will be downward direction, which means what? Mg is more than that of the Fr. Here why these two are added? Because both are in the same direction. But here as both are opposite direction, we have to subtract that. So this will be mg minus Fr. This is the net force acting by mass. So now A is equal to, you can take m as a common, this is G minus frictional force by mass. So this is the net force acting, net acceleration acting in a body when it is coming downward direction, provided air resistance is considered. So now this is acceleration, right? Now let us write the, what we can say, time of descent. So time of descent is equal to now time of descent is equal to initial velocity by net acceleration. Net acceleration, how much we got? This much we got. G minus friction force by mass. So this is how actually we can calculate the time of this. And if you can see here, the very important point here. So time of ascent or time of descent, children. So here it is, see here, initial velocity remains constant. Means what here? This time of either ascent or time of descent purely depends on the acceleration. Now which one is more? Here obviously the plus, right? So here the denominator is more. As the denominator is more, obviously this time of ascent will be less. Here as a denominator is less because of subtraction, right? Because from the G you have to subtract this value, whatever you get. So denominator is less. As the denominator is less, children, here you get a more value for this time. This time means what here? Time of descent. So hence we can say that here time of ascent is less than time of descent, or you also can say time of descent is more. So this time of descent is more, try to understand, than that of time of ascent. The reason is very simple, children, here. So here during upward journey, net acceleration will be more than that of the during downward journey. So as here the net acceleration is more, time of ascent is less. Here as the net acceleration is less, so the time of descent is more. So it's clear that time of ascent is less than the time of descent. Okay children, thank you so much, all the very best.